So Fran, you've talked about materials, processing, and all of these things we can do to improve the performance of gears or other types of applications. But specifically in the area of gears, PM and its natural shape-making capability, its inherent shape-making capabilities, is there something we can do as far as shape with the gear in terms of assisting in that improved performance?
Yeah, and there is. And again, take a step backwards. You know, if you look at a transmission gear, for example, you know, typically it's a helical gear and it's equal on both sides, what they call the running side and the idle side of the gear. There's been some work done by Anders Floden at Hägernäs of Sweden.
Dr.
Floden, yeah. And what he suggested was that when you look at a gear in most automotive transmissions, it's only loaded on one side. So what he proposed doing was changing that shape of the gear to put more metal on the loaded side. So now the load is going to be distributed, you know, across more metal. So you then eliminate some of the frailty, if you will, or the fragility of the gear using PM. He proposed it. I mean, they've had only moderate success with it. And again, it comes back to what we were talking about earlier in the sense that it's not commonly accepted to do it. But it does suggest, as you say, that, you know, what PM can offer is this uniqueness.
Right. And as we start combining a lot of these individual solutions, such as the shape of the gear, the advanced compaction process, the ultra-high temperature sintering, as you start combining all of those together, now
you really have, you know, something very, very interesting. As you say, you know, the advanced compaction technology is you know, definitely a big step in the right direction. You know, and high temperature sintering and ultra high temperature sintering is really important. And again, it's important to note that, you know, ultra high temperature is something that we are promoting. It's been done in other areas, if you will, within the PM.
Sure.
You know, people have used it to sinter stainless steels and things of that sort. But very few people have applied that or utilized that in the actual structural, relatively low-cost steel aspects of PM. You know, those that do are using a vacuum. Well, vacuums are nice. They have certain problems associated with them, mainly being very long cycle times. So if you can do this on a much more commercial scale, you know, what would seemingly lower cost, it's an excellent opportunity to do it. And again, the work that we've seen in the industry, no one else has done this before, so it is definitely a unique opportunity to, as you say, with shape making, unique alloys, and advanced compaction, you know, it makes a real nice package to look forward to.
That's great.
And even another point, if you think about, you know, we talked a little bit about the electrification of the vehicles. Now, suddenly you don't have this massive dump of the energy from the engine. It's more continuous from the electric motor. Does that represent an opportunity that suddenly, well, maybe we don't need a wrought gear in that gear train?
Yes. Right.
Can we now merge SMCs in the motor with high temperature or ultra high temperature sintered PM gears to give us a very PM intensive gear train or powertrain assembly?
You bring up a great point. Is that also create an opportunity for maybe cost reduction opportunities for things like connecting rods?
Yes, yes. I mean, again, if you use the hybrid vehicle approach,
right,
or, you know, the Chevy Volt was a good example. You know, it had an auxiliary engine, but that auxiliary engine simply just charged the batteries. It was never used in propulsion of the vehicle. But that engine's running at constant speed. So you could theoretically now design a connecting rod to live in those kinds of environments because it's not going to see the heavy stress of, you know, rapid acceleration and things of that nature. So that's an excellent opportunity, and it's something that, you know, is very worthwhile looking into because that it solves two problems. The range anxiety issue of suddenly, oh, I'm going to get 50 miles away from home and I'm suddenly out of battery life. Now what do? I walk. But then the other side of it says is that, you know, I had this flexibility of saying, I want to drive from here to Michigan. I can do it nonstop.
Right.
You know.
Yes.
Run the gas engine and kicks in very nicely with the electric side of it as well.
Right.